Hello everyone, NadLabs here. Today we're going to be making this very simple circular joystick in the Godot Game Engine, version 3.2.3 stable. I just want to make a couple things clear. I've already made a joystick video on this channel. It's a square joystick. It should come up in the top right. Hopefully, maybe, somehow. If I forget, please let me know. But essentially, that was a square. You could only move from left to right. And you can see that this one's a lot different. This is a circle. I was actually requested to make this in the comments, and I made it. And I was like, hey, this is pretty good video idea, and here we are. So let's get right into it. So I'm actually going to assume that you didn't watch the second video, so you don't have to go watch it. I'll just give you a full walkthrough of how to make it. So essentially we're going to need a couple of things. We're going to need a player. Our player can just be a kinematic body 2D. I also have a simple tile map over here. You can see I'm using the Godot sprite, and I just set the region to the entire sprite itself. I just went like this to make it, and then I went to the collision shape and I just made sure it was the entire length of the shape. I don't need to make another one, but you can see you just have to drag it over the corners. Then your tile map's ready to go. If you're wondering how I made them black, I just dragged the modulate down over here to black to just give it the sense of a wall. The background over here is just a regular old sprite. I'm pretty sure I'm using the Godot sprite. Let's check. No, this is actually just a regular black sprite, just black.png, 4 pixels by 4 pixels. I just stretched it out, and that's about it. You don't need these, obviously. Like I didn't need this, but it gives a little backdrop to the joystick. That's something to keep in mind if you're making a game. Now we're going to go over a couple settings you need for the project. You want to make sure that in your input device's pointing, you have emulate touch from mouse. This means that if you press onto the screen of a mobile phone, it will count that as a mouse press, like as if I'm pressing the mouse. And that's something you have to keep in mind, because if you're using a joystick, you're probably making it for a mobile game. Let's be real. You also want to make sure that you keep your mode to 2D and your aspect to keep. I usually do this. You can also use viewport. It doesn't make a difference, but just make sure you use keep, because it helps keep the same size of the sprites and everything across different screen resolutions. I'm pretty sure that's all I had to say, so let's get right into making this. So we're going to start off with the player. You're going to want to attach a script, so I just go over here to this green icon, and I just click create. It'll say create for you. It says load for me because I already have it. And essentially we're going to say something like this. We're going to be making a variable called velocity, and with that velocity, we're just going to tell our player to move and slide by that velocity. We're also going to set the velocity equal to the move and slide, because if you see the documentation, it says it returns, where is it? It returns a linear velocity, and it's just a lot more smooth and helps with our movement. It helps with the player movement. Just a quick note, you don't need it. The game would still run perfectly fine if I didn't put this. Then we're going to move on to the joystick. So to create the joystick scene, all we really need is a node 2D, and then you can attach a front and back sprite to that. So again, just attach a script and we'll start coding it. So of course I start off with an empty script, and of course it says it is with a node 2D. So I'm just going to go into distraction free mode and let's start coding this. Okay, so essentially what we want to do is get a couple of variables going. We want to make sure we get reference to our front and back sprites. We wanted to set an ease value. The ease value essentially states how smooth, of course it doesn't work because I have no code in, but essentially states how smooth the transition between the front and back will be. And yes, I just copy pasted it in, but essentially it explains how smooth this will be. So you can see how when I let go, it goes straight to the center. It glides into the center. The higher that value, so let's say I had 9, it'll be a lot less smooth. It'll just be a lot more jagged. It's like teleporting almost. And the lower it is, like 0.01 basically, you can see that it basically takes forever to move to where it's going. I found 0.25 is the best, and that's just my preference. After the ease value, we're going to decide the range of the joystick. The range of the joystick essentially states how far can we go. So if we have it's easier if I go over here. So if this is the front, it will explain how far can we go. We don't want it to go all the way over here, because now we're at 1000 pixels away. I don't know if you can see it, but that says 1000. We're 1000 pixels away from the center of the joystick. That's not good. We want something like 250, maybe like a circle around 250. So the radius is going to be 250. So essentially this is the radius of your joystick. Then we're going to get a screen size. I'm just going to set it equal to a vector 2. We don't really need to set a value to it because we're going to change it as soon as the frame loads. And speaking of frame loading, as soon as the ready function is called, which is called exactly when the node is ready, for example, when it enters the scene and is fully ready with all its children and ready to go and start being modified by code, it will set the screen size equal to the viewport size, and that essentially gets us the numbers that are in our project settings, and then our size of width and height. Of course, you can hard code them, but if you ever change them in the future, you're not going to easily figure out where the bug came from. In our process function, we want to have everything related to the front sprite in one function. Now it's Godot screaming at me because I haven't made the front related function yet, so we're just going to add that in, and you can see that does nothing. So if we reason from first principles, which is essentially taking what is known to be true and working down from there, what do we need for our joystick? And I'm just going to put a couple lines there because I like doing that. So I'm just going to paste a couple lines of code here, and I'm going to explain what they do. So we want to get the mouse position. Getting the mouse position is important because we want to be able to compare the position to certain areas, and we want to be able to clamp it later on, maybe shorten it so we can get a smooth circle radius, to get a smooth circumference of the circle. That will come in handy later on. But we also want to say that when we are clicking, so what is clicking? If we go to our project settings, into our input map, and we type in click, we can make an action called click, but obviously I already have it. You can just click add, and when you scroll down, you'll see this thing. Most likely it will look like this for you. So go over here to mouse button, click all devices, add, and you have click ready. So essentially what we're going to be saying is when action click, so while we are clicking, we're going to set the front, right? The front is the front sprite. We're going to set the front sprite's global position equal to where the mouse is. But obviously we can't do that because it will look really disgusting, and I'll show you what I mean by disgusting. So if we just set it equal to the mouse position, we're going to get something like this. Yeah, it looks like it's just teleporting to our mouse, right? The reason it's slowly fading back or moving to the center is because we're actually using the lerp function, and you can actually see the difference between setting the position directly and using the lerp function. Lerp is just linear interpolation. It just basically moves something closer to another place. The best way I can explain it is, imagine if you had, this is point A, and over here you had point B, and this is the position. Well, basically what's going to happen is P is going to start moving across the screen ever so slightly. So this is frame 1, right? Frame 1, frame 2, then frame 3, and it'll just give the illusion of moving over to the second position, which is B. That's the best way I can explain it very quickly. And let's actually replace that. So actually I want to give a quick challenge to help your understanding of Godot increase. Why don't you try writing out what the lerp function for this will look like? So essentially we want to say something like when we're clicking, we want to move from where we are right now, which is the front.global position, to some other place, say like the mouse position, by an ease value. Try typing that out, and I'll show you the answer when you come back. Hopefully you tried it out. If you're not, that's totally fine. But essentially we want to write something like this. We're going to lerp from the front position, where we are right now, to the mouse position, where the mouse is, where we're touching, and then we're going to move by an ease value, because the lerp function takes in a weight, which is that ease value we talked about at the beginning of the video. And you can see right now I have something like this. Basically it smoothly goes to where I am, and that's pretty cool. And now I just noticed one quick thing. If you're trying this out and you're actually building this little step by step as I'm showing you, you're probably getting the idea that your sprite isn't moving or your player isn't moving. It's because I haven't actually explained how we set up the movement stuff. So don't worry about that. That will come near the end of the video. I just want to make that clear, because right now we're setting up the circular part of the joystick. After we get this simple movement set up, we want to make sure we can clamp this mouse position, or we want to make sure we can restrict it. Well, how can we restrict it? So if we go to the Vector2 documentation, which is where I go if I ever want to know anything about a certain class or object in Godot, I just scroll down and see what I can play with. And obviously when I was making this, I was just looking, and I was like, I really want to like clamp or like stop this, and I saw clamp. And I was like, okay, what's clamp? It returns the vector with a maximum length by limiting it to the length of okay, well, that doesn't make sense, but basically means that we're going to limit the vector's length. But the reason it sounds a little confusing at the end is because this length in a slightly blue color, I don't know if you can see it, it's in like a different color and font, is actually referring to this length over here, which we can pass in. So if we go over here to our joystick, we want to say something like the global mouse position is clamped to the range of the joystick. We can see what that looks like. So as soon as we touch, you can see that it's over there. And why is it over there? The clamp function actually returns a vector, and it actually sets a position for this mouse position. The issue is that this position is from 0, 0, which is the absolute corner or the top left corner of the screen. We want to make sure it goes back over here to the center. one way we can easily solve that is by saying back dot global position. We're just adding, so essentially what we're going to be doing is saying, okay, sure, you can clamp the front position, but then make sure you bring it back over here. And if we run it, we get something like this. But you can see it's a little bit weird because we're still getting our mouse position, with reference to this top left corner. Well, how do we fix that? Well, instead of doing the global position of the mouse, we can just get the local position of the mouse. And we can see that makes all the difference. Now, why does that make all the difference is a very good question, which you may or may not be wondering. Well, the reason that we cannot use the global mouse position is because the global mouse position is, well, if you think about it, the global mouse position is like a vector of like, if I'm over here, it's like 10,000 by like, it's like 1920 by 1080. And if I use the local mouse position, in fact, let's just keep on printing the local mouse position and the get underscore global mouse position. And let's just separate them with a space. And let's see the difference. Okay, so after looking at this for a bit, I can now explain why we have to use the local mouse position. You can see that while I'm over here near the center of the joystick, over here in the bottom left, you can see that it says it's really close to 0, 0. Like the closer I bring it to the center, the closer it gets to 0, 0, and that means that it's measuring from the center of the joystick. Whereas if I use the global mouse position, I actually have to go over here to the top left in order to get 0, 0. So if I'm using the top left to get my 0, 0, then obviously when I'm dragging my mouse over here, it's dragging the mouse relative to this point in the top left. Whereas if I use the local mouse position, it will measure everything from over here, and I can easily get these angles saying if I want to move left, I have to be on the left of the joystick. If I want to move right, I have to be on the right of the joystick. Whereas if I was using the global mouse position, I would have to be on the right of the corner, and then I have to be on the left of the corner. If you're making a mobile game, you know that you can't be on the left of the screen size. You can't be on the left of the left screen because that means you're clicking outside of the screen, and that doesn't make any sense, nor does it make sense to be on the top. So we have to use the local mouse position. I hope that makes sense and satisfies someone's curiosity as to why we can't use the global mouse position here. So it looks like, if we run the scene, we have a fully working circular joystick. And it's a lot less code from the square one if you saw the previous video. If you want to make your joystick dynamic, whereas it will start moving to where you just clicked, we can basically do that with this block of code. And I really hate to admit it, but these values have to be hard coded. Of course, you can set up some mathematical equation to set them up, but essentially if you just grab over here in the top left, or if you just grab anywhere on the rulers on the sides, you can get these purple lines, and Godot will help you just place objects around. So you can see that this line up here is the maximum I want the joystick to go. Of course, Godot doesn't know how to get these values, so we just have to eyeball it and see where is the best place for this joystick back to go up to. So you just want to say something like, maybe let's say like 1250. I think that's a good place to go. And of course, then we have to do the bottom, which is like maybe like 1750. And we're basically saying that just figure out where this event.position.y is, and if it's less than 750, greater than 1250, so if it's less than 1750, so somewhere up here, and if it's greater than 1250, which is somewhere down here, so that creates an overlap in this area. If it's in this area, just make sure we can set the back.global position to where we clicked, and that's exactly what we get. You can see that I'm able to move the back over here, and I'm able to move my joystick around perfectly normal as if it was somewhere else. Now, of course, this creates an issue for people who are like, maybe they're playing on the subway or something and their left thumb was over here. So you have to keep these things in mind if you're making a game for mobile. So you can see I'm not clicking down here, which is good. I'm not clicking where the player is, which is good. But the issue is now that if I'm like over here on the top left, if I want to move to the left because a bad guy's there or something, then that creates an issue. Just keep that in mind. And now I'm going to explain how you can get the game scene and the player to actually start moving to your responses. So what we're going to be doing is a little bit of vector math. So what we're going to be doing is we just want to get reference to our front and back sprites. We can just do that by going to the joystick and getting the back sprite child. And we want to get a reference to our player. After that, you just want to set a speed multiplier, how fast you want your player to go. Of course, this will be discovered through trial and error. I found 3 was perfectly fine for me. And I just realized that you don't need these 3 variables. Those are obviously from a long time ago. And I'm just going to try making this simpler. So there's just a couple things we have to do. We just have to create a vector, which is So what we're going to be saying is every frame we want to make sure we can get the player's velocity based on the difference between the joystick front and back. Because if you really think about it from first principles, what is a joystick? It's basically a relative movement system. So you're going to be moving relative to where the front and back is. So if the front's in the top right, you're going to be moving towards the top right. Or you're going to be moving in this direction, where the front minus the back. And that's key to remember, front minus the back. That's essentially what we're going to be saying. Front dot global position minus the back dot global position. And if you're confused as what does that even mean? Well, if you're confused as to what does the front dot global position really mean, or the back dot global position, what does that really mean? Well, I can easily go to my trusty old Paint and show you what that means. So let's say this is your game, and you have your, let me do it in red. The front is red. That's your front, and let's say your back is, I don't know, blue, B and blue, back. Oh my god, that's kind of a tongue twister, but whatever. Oh, what? Hello? Oh, okay. Nope, that's weird. Okay. Let's say this is your back and this is your front. Godot basically says that the global position is going to be measured from the top left, as we saw. So we're going to get the global position for the front, and now we're going to get the global position for the back. Nope, wrong color. And what subtracting the vectors, oh my god, what subtracting the vectors basically means is, if you just give me a second, this is the direction of this vector, this is the direction of this vector. What subtracting the vectors basically means is that we're going to be getting them. So let me just make a copy of them over here. So this is the front, and this is the back. To subtract vectors, you want to put them from head to tail. So we're going to be taking the head of the front dot global position, and we're going to be aligning it to the tail of the back dot global position. So if we did something like that, it would look like this. But that's vector addition. In vector subtraction, you do the exact same thing, head to tail, but you're going to flip the direction. You're going to flip the magnitude, which basically means that we're going to go in the opposite direction. So you can see how this arrow, or this the blue one, is pointing downwards. Well, this one's going to be pointing upwards. And because it's pointing upwards, the tail, so to speak, is now down here, and the head's up here. Now, if we go for yellow for resultant, we're just going to trace our. If we go yellow for resultant, we're just going to trace our path, and this is the direction we should be going in. And you can see it's the exact same thing. That's all vector subtraction is, and that's what we're doing. So, but we're doing this in a function called values between front and back, and it's returning a vector too. We return a vector, and we're just going to be using this to set the player velocity to front and back, and we're just going to be using a speed multiplier. Now, of course, when I run the scene, you get this. Very simple. I feel like the Godot sprite isn't showing up very well. I just realized that. I might make it a little bit bigger. And this is how you make it a little bit bigger. You just grab, holding Alt, and you can hold Shift if you want, I guess, but holding Alt is more important. Oh, it just throws an error when it's too small. And let me just make the closing shape a little bit bigger. Let me run that now. You can see that Godot moves to wherever the front minus the back is. Front dot global position minus the back dot global position, of course. And now if you want to have rotations, you can just do a little bit of math there, and this is what you'll get. Mind you, it looks a little bit jerky just because of the way that angles work in Godot, but this is basically what you have to say. If you want to use the rotation, you have to say player.rotation degrees is going to be equal to front.global position dot angle to point, which will do all the math for you, all the trigonometry. Godot will calculate everything for you, and it will spit out an angle, which is in degrees. And I believe if you use angle 2, it already gives it to you in radians, so you don't actually have to do anything. But don't mark my words on it. Just use something like this. 1 second. And you'll have angles and you'll have movement. I personally don't like the angles for this particular example because this is just Godot moving around. In fact, let's run it with this. Yeah, it doesn't look that bad. I mean, if you're making a top-down game, it would look a lot better. But anyway, that's this tutorial on how to make a circular joystick in Godot. And if you ever want to get rid of the dynamic, if you ever want to get rid of the dynamic aspect of it, just make sure you get rid of this function input line block of code, and we'll be good to go. Well, that's all I have to say for this tutorial. And of course, I'm going to be doing a mobile demo showing you how this works on the Android phone. So I'll see you right there. And just one last thing to note, all the code is on GitHub, link in the description. Okay, so I'm back on my phone, and I'm just going to center it, and you can see that I can drag, and it's a circle. You can see that there is a circle, and everything's working as it should. Like, Godot's moving around as it should, rotations are happening. Of course, if you pass by the middle, it goes quickly. Of course, the audio quality is different because this is my tablet, not my regular mic, and yeah, that's about it. Have an amazing day.